Morning students. Now we are going to discuss about commercially available FPGAs. So here we have listed what are all the commercially available FPGAs. Their vendor names is present here. One is Xilinx, Actel, Altera, Blessy, plus AMD, that is Advanced Micro Devices, Quick Logic, Alcotronics, Concurrent, Crosspoint. So these are all the commercially available FPGAs. So what is the general architecture is given in second column. The third column, what type of logic gate it is used and what type of program technology it is used. General architecture is nothing but already we have seen the type of architectures used for the FPGAs. One is symmetrical array, second one row based array, the third one hierarchical PLDs, the fourth one C of gates. These are four architectures used for FPGA. So here they have specified which vendor used for which architecture. The second one, what type of logic block is used in this. First one, there are three types: lookup table, multiplexer based, programmable logic device based, and NAND gate based. So these are all the four logic block types are used in FPGAs. So the another one, the programming technologies. The programming technologies is nothing but static RAM, anti-fuse, EEPROM. Okay, these are all the three programming technologies. So this this table shows that which the company or vendors prefer which architecture and which logic block is used, and these logic blocks are programmed such a way that what type of technology they used. So that is specified in this table. Now we can see general architecture of Xilinx FPGA. So this is the commonly used vendors for all the type of FPGA. So it consists of configurable logic block, then programmable interconnect is nothing but horizontal routing channel and vertical routing channel. Then the I/O blocks are present at the outer ring of the general architecture. So these three components are very important. The next one, we have Xilinx. There are many versions are present. So we have seen now 4000, the Xilinx 4000 configurable logic block. So the Xilinx 4000 configurable logic block consists of three lookup table 3. Okay, so two lookup table has 4 inputs, one lookup table have 3 inputs, then it has two multiplexers. Okay, the two multiplexer is going to be connect the lookup table with the flip-flops. So the flip-flop is used to send the proper outputs. The other block to have carry propagation. Okay, that is carry forward. Then you have a state. The state block is used to set and to reset the flip-flop. If it set the flip-flop will give the output 1. If you reset the flip-flop will give the output as 0. The next one, the 4000 programmable interconnect. So programmable interconnect is nothing but making connections between the configurable logic block and the I/O. Okay, by use of the switch blocks and the connection blocks. So this is the general structure of the programmable interconnect. It has single length lines. So you look at all the lines are single lines. These lines are connected to the configurable logic block with the routing switch. Okay, so these connections we call it as a wiring segment. Each switch battery point consists of 6 routing switches. Then the Xilinx 4000 has double length lines and long length lines. So if you see the horizontal long length, then you have a 6 route switches using the double line length. So this is going to be connect the configurable logic block with the global that is clock and supply and input output lines. So the next one, general architecture of Actel FPGA. So the Actel FPGA, it has, so this is called logic blocks. Then this is called the channel routing. It has only the row-wise channel routing. Then the outer lines we have a I/O blocks. This is the logic module of Actel Act. Okay, it has two multiplexers. It has three multiplexers, 1, 2, 3, and the select lines used to select the respective multiplexers. Now, this is nothing but the programmable interconnect architectures. So, it has a input, that is row based input and output segments. Then dedicated vertical track is used to connect the connections. At the same time, it has a anti-fuse links is used to program the horizontal lines with the logic modules. So this is about the logic module and the programmable interconnect architecture of Actel Act. So this is the general architecture of Altera FPGAs. It has logic array block. You have a programmable interconnect array is used to connect logic array block with input output control blocks. So this is the general architecture. It has logic array block, programmable interconnect array and I/O control block. It has the logic array block consists of array of macro cells and expander product term array. So this is nothing but there is the Altera. So this is nothing but the Altera macro cell. So the macro cell consists of, you have the exclusive OR and you have a flip-flop, D flip-flop. It has set pin and a reset pin. Okay, then it has a state line. This is going to be used to enable the clock. So output taken from this. So the macro cell consists of exclusive OR and multiplexer, one D flip-flop, then you have a states. Okay, so this is nothing but the macro cell. The next one you have the product term array. The product term array is nothing but there are n number of product terms. These product terms is used to connect programmable interconnect array cells and logic array block expander product term. Then you have a macro cell feedbacks, that is from the macro cell the output is connected to the feedback of the product term. So this is the expander product term. Depending upon the logic expression product term, these terms are fabricated. So this presentation it's pointed out what are all the commercial FPGAs are available, and we have seen Xilinx, Actel and Altera, the configurable logic blocks and the programmable interconnect array. Thank you.